This video is for Chemistry in the Earth System, Unit 3.3, Covalent Bonding. Today's essential question is, how does the formation of a covalent bond relate to the octet rule? Our first main idea, covalent bonds and electronegativity difference. When two atoms form a chemical bond, the difference in their electronegativities can be used to classify the type of bond that forms. Electronegativity measures the ability of atoms to attract electrons.
Electronegativity measures the ability of an atom to attract an electron.
An electronegativity difference of 1.7 or higher indicates a transfer of one or more electrons and the formation of an ionic bond. Remember, ionic bonds often form when metals bond with nonmetals. An electronegativity difference below 1.7 means that neither atom attracts electrons strongly enough to allow the transfer of an electron. Instead, the atoms share electrons and form a covalent bond. Covalent bonds form between two non-metal atoms because the atoms have generally similar electronegativities. The covalent bonds can be classified as nonpolar or polar bonds based on the equal or unequal sharing of those electrons. Non-polar covalent bonds form when the difference in electronegativity between bonding atoms is between 0 and 0.4. Electrons are shared equally between the atoms. Polar covalent bonds form when the electronegativity difference is between 0.4 and 1.7. This results in unequal sharing of electrons. One atom with a higher electronegativity will draw the bonding electrons toward itself, pulling those electrons away from the atom with the lower electronegativity value. The atom with the higher electronegativity becomes partially negatively charged, and the atom with the lower electronegativity becomes partially positively charged. This makes the bond polar. Examples of atoms with a polar bond are water, as you see on the screen here, and ammonia, which is NH3. Our next main idea, the octet rule and Lewis structures. The elements of group 18 are the noble gases. They are non-reactive nonmetals. These elements exist naturally as individual atoms, but what makes these atoms unlikely to form chemical bonds? Think about the number of valence electrons that are in the outermost energy level of one of these atoms. Each noble gas atom has 8 valence electrons, except for helium, which has only 2 valence electrons. A convenient model to show the valence electrons in an atom is a Lewis structure. In this model, an atom's nucleus and inner electrons are represented by its chemical symbol. A dot is used for each valence electron. For example, the Lewis structure for a neon atom begins with the chemical symbol Ne for neon. This symbol is then surrounded by 2 dots above, below, to the left, and to the right. The dots that surround the neon symbol represent neon's 8 valence electrons. Atoms that have 8 valence electrons, and the exception being helium with 2, these atoms do not tend to react with other atoms. For other atoms, however, they tend to form chemical bonds such that they put 8 electrons in their outermost energy levels. Remember, the octet rule describes the tendency of atoms to gain, lose, or share electrons until they have 8 valence electrons. Next main idea, single, double, and triple bonds. The Lewis structure of a fluorine atom shows that each fluorine atom has 7 valence electrons. A fluorine atom, therefore, needs only one more electron to complete its octet. If a fluorine atom shares one of its electrons with another fluorine atom, the valence shells of both atoms become filled. The two shared electrons form a single bond between the atoms. A single covalent bond is composed of 2 shared electrons. In the Lewis structure for a fluorine molecule formed in this way, a single line can be used to represent the shared electron pair. The Lewis structure for oxygen also shows that each atom has 6 valence electrons. An oxygen atom needs 2 or more electrons to complete, 2 additional electrons to complete its octet, going from 6 to 8. A single bond with another oxygen would not fill the octet of either oxygen atom. Each atom would only then have 7 valence electrons in its valence shell. Instead, oxygen forms a double bond, and they share 2 pairs of electrons between them, meaning 4 total valence electrons. In this way, each oxygen atom completes its octet. A triple bond consists of 3 pairs of electrons shared between the 2 atoms, a total of 6 valence electrons. What kinds of atoms can form a triple bond? An atom must have room for at least 3 additional electrons in its valence shell if it is to form a triple covalent bond. A nitrogen atom has 5 valence electrons, so it needs 3 additional electrons to complete its octet. 2 nitrogen atoms can form a nitrogen molecule by sharing 3 pairs of valence electrons in a triple covalent bond. The Lewis structure for the nitrogen molecule shows the triple bond as 3 lines between the individual nitrogen symbols. At this point, you should be able to generate a full and appropriate response to today's essential question. How does the formation of covalent bonds relate to the octet rule?